Good morning, ladies and gentlemen. Dr. John Belkowitz here, Intelligent Concrete. Real excited about this question today from One High Voltage One, because it's Q&A day. Ding! One High Voltage One asks, John, I guess this is a statement. John, you stated that the design of a high-performance concrete involves reducing the paste content. I know one of the key factors for HPC is a very, very low water cementitious ratio and an extremely packed inert skeleton. However, I thought HPC had a rather high cementitious content. Why do they want to reduce paste cost? Is it cost or is it shrinkage reduction? One High Voltage One, thanks for your question. And I never said that the design of an HPC had to involve reducing the paste content. I said that to increase the robustness of your higher performing concrete, you normally want to reduce reduce paste content and optimize and then increase your granular skeleton. And by saying optimize, I mean reducing the porosity index by creating a gradation envelope. Well, you know, one of the key factors, you're right, is using a low water cementitious ratio, but not necessarily a very, very low water cementitious ratio. We've been able to create high performance or higher performing concretes with a 0.35 getting 12,000 psi 28 days and 15,000 psi at 56 days. So you don't necessarily have to go down to the 0.32s or the 0.28s that folks do for UHPC, and I think it could be argued even for UHPC you don't have to go that low. So yeah, you can have a higher cementitious content for, oh my goodness, how are you going through? I'm literally on airplane mode. What? Oh, it said message failed to send. Oh. You know, for the HPC, you can have a higher cementitious content. Just remember, or higher paste content, by increasing paste content, more often than not, you're making that mix more sensitive to blowing up or segregation. So why do we reduce paste? I think I've said it a number of times. By reducing paste through a change to the granular skeleton, by reducing the porosity index, and then of course increasing the granular skeleton, reducing the paste content, you can have a value-added performance reduction on cementitious and of course cost. But more so, you can also have an increase in durability. Some rocks can be stronger than our paste content, and then also by reducing our paste content, we're reducing the very mechanism that goes through volume change, which of course is associated with shrinkage, and then of course cracking. So One High Voltage One, thank you again for an awesome question. Hopefully we answered it. Don't forget to like and subscribe. Go Concrete!
Beat asphalt!